Hello everyone, welcome to Exponential Functions. Now we've just studied quadratic functions and linear functions. We're going to learn something new, but let's review what we already know. So we know linear functions basically have the shape of a line, and quadratic functions have the shape of a parabola. And we can identify whether a function is linear or quadratic, whether we look at the table, whether we look at an equation, or whether we look at a graph. So let's look at the first table. Let's see if we can figure out whether it's linear or quadratic. Now we remember we check if our first differences are constant, it's linear. If our second differences are constant, it's quadratic. So follow along with me. These are plus 1. And on this side, 0 to 3 is plus 3. Continue on. All my changes in y are constant. This is a linear function. Let's see what it looks like. There it is. That's line. This is a linear function. It's a function, passes the vertical line test. Go ahead and do your first differences on the next table and see if it's linear. If it's not linear, let's keep it going and see if it's quadratic. -3 to -5 is -2. -5 to -3, I'm going up 2. -3 to 3, think about the number line. I'm going up 6. 3 to 13, I'm going up 10. Well, this is definitely not linear. Let's see if it's quadratic. -2 to 2 is going to be 4. 4 also. Anyone see a pattern? Bam, this thing is quadratic. I know its shape is going to be a what? A parabola. Let's see what it looks like. That's not right. Can you see that? It's going to be a parabola. Here's a vertex down here. Axis of symmetry of this thing looks like it's 0. Ish. Okay, ish. So this is quadratic. Let's talk quickly about equations. I know for a linear equation, the highest power for that x is 1. Y equals x plus 7, or 2x plus 3y equals 9. You can see that the exponent for the x variable is 1. It's a linear function. Now with a quadratic function, the highest power for the x variable is 2. So you could have y equals 3x squared minus 4. Or you could have, y plus 3x squared minus 6 equals 37x minus 15. But in any case, the highest power of that x variable is 2, and that's a quadratic. I know its shape is going to be a parabola when I graph it. Now this is an example of an exponential function. I'm just going to let you see what it looks like since I know you want to see it. Looks like this. That was wrong, sorry. It's kind of going down. What I want you to know is that this thing is going down lower and lower and lower, but it's actually getting closer to 0. It's never going to cross this x-axis, but it is going to get really, really close to 0. It'll be like, a half, and then a fourth, and then an eighth, and then a 16th, and it'll keep on getting smaller and smaller and smaller until it gets really close to 0, but it'll never hit 0 in this particular function. Now, this does not have common differences. Thing called common ratios, and ratios have to do with multiplying and dividing. And so let's see if we can figure out some kind of relationship between the values of y. I know that these are all plus 1, so you can get that set up. Now, what do you notice is happening from going from 1.5 to 3, 3 to 6, 6 to 12, 12 to 24, 24 to 48, 48 to 96? I am doubling. I'm multiplying it times by 2. So here we go. So 1.5 to 3, the relationship, I'd multiply it by 2. The relationship between 3 and 6, I'm multiplying it by 2. Multiplying it by 2. When you have this case, it's called an exponential function. It's got constant ratios. Now what an exponential function looks like is y equals abx. These are numbers. And my variable goes right here. So we're talking about something squared, something to the 0 power, something to the first power, something to the second power, something to the third power, something to the fourth power. Because this x variable here actually becomes the exponent. But we'll do some examples of those in class. Right now, I just want us to look at a table and figure out whether it's an exponential function or not. Okay? And if it's not, we'll figure out what kind of function it is. So let's look and see if this is an exponential function. Let's see, I know that it's got common changes in x. Let's check my changes in y. Let's see if it's got a common ratio. Negative 9 times what gives me 9? Negative 1. Negative 9 times what gives me 27? 3. 9 times what gives me 27? 3. 27 times what gives me 45? Oh, I got to write an algebra equation for that one. So 27 times r for ratio, I'll just say, equals 45. I got to figure out what r is. So what do? How do I get r by itself? Divide by 27. And I get r is, 45 over 27, which is, divide both by 9, I get 5 over 3. Yeah, this is absolutely not a exponential function. No. Let's see if we can figure out what kind of function it is. Do your first differences and second differences. Figure out if it's linear or quadratic. If it is, write it here. Go ahead and pause me. Now let's look at it and see. Looks like a linear function to me. Hopefully your first differences were all 18. Let's see if this is or is not an exponential function. It's an exponential function if the ratios are common. So let's see, 0.75 times what gives me 3? 0.75 times what ratio gives me 3? What am I going to do? I can divide both sides by 0.75. You can try that to get your answer. If you'd rather work it as a fraction, which is easier for me, you could say 3/4 times r equals 3. And how do I get rid of this 3/4? I want that to be 1. I multiply it by its reciprocal, 4/3. And then what do you get for r? Keep on working this. If it's an exponential function, let me know. If it's not an exponential function, see if it's a linear or a quadratic. And write the answer right there. Okay. Prove that this is or is not an exponential function. Same thing. See if you can do see if you can do common ratio. 1 times what gives you 0? 0 times what gives you 1? 1 times what gives you 4? If it's not coming out to be a common number, then see if it's a linear or a quadratic, and write your answer here. Going to help start you off on this one. Let's see if whether it is or is not an exponential function. 4 times what gives me 2? Let's see. 4 times R for ratio gives me 2. How do I figure out what R is? Divide both sides by 4. And I get R is equal to 2/4, which is the same thing if I reduce it or simplify it to 1/2. So my first ratio is 1/2. You can keep on working and see 2 times what gives you 1. 1 times what gives you 0.5. See if you have common ratios. Okay, we're going to evaluate this exponential function. This is an example of an exponential function where the variable x is actually the exponent. So I have -2. When x is -2, what is y? Let's see. Y equals 3 to the what power? To the -2 power. You remember what to do with a negative exponent? Ticket to ride. That's the same thing as 1 over 3 to the second power. What is 1 over 3 to the second power? Just 1/9. Okay. See what happens when x is -1. Y equals 3 to the -1 power equals, remember that's ticket to ride, 1 over 3 to the first power. That's just 1/3. Let's do y equals 3 to the 0 power. Anything to the 0 power is 1. Y equals 3 to the first power. So that's just 3. Y equals 3 to the second power. That's 3 times 3, which is 9. 9. I'd like you to do the next table. In this case, this function is y equals 2 to the x power. If you can fill that out. In my last page, we're just reviewing something that has nothing to do with this lesson, but I need you to practice this for our upcoming EOCs. So I want you to practice solving for y. I'll do the first one with you. So if I want to get y by itself, because that's how you can actually enter this equation into the calculator, it's got to be in y equals form. So I want to get y by itself, so I'll subtract 4x from both sides. I end up with -5y equals, these are not like terms, I can't combine them, I got to keep them separate. -4x minus 10. And I want y by itself, but it's multiplied by -5, so I have to do the opposite, or the inverse function, which is to divide by -5. And if I divide this side by -5, I've got to divide the whole thing by -5. So I get y is equal to, remember the butterfly thing? So I'm going to write it over here. Let me erase the butterfly thing. Okay. Leave chain, change this right here. Make it easy for yourself. Y equals -4 over -5x. That'll simplify to 4/5 x plus -10 over -5, which will be 2. I'd like you to do 2 and 3 on your own. Don't forget this -y is just like a -1y. Or minus y is like a -1y. And I will see you in class.